Hello guys, I am Yasir Ali, and here in this tutorial we will discuss surface weight versus set down force graph. This graph is basically generated using the cultubing software Cerberus, and this graph comes under the heading of working at depth graph. So let's discuss, that is surface weight versus set down force graph. But before going ahead, just let's recap about our previous tutorial, that is maximum overpull and set down weight, which also comes under the heading of working at depth graph. So in this particular tutorial we discussed that how to interpret this particular chart, which is basically a maximum overpull and maximum set down force, that is in a particular well and using a particular coil tubing, what will be the maximum overpull that we can apply and what will be the maximum set down, that is slack off, which we can apply. So this was we have discussed in this particular tutorial. Its link is shown on this I button, so you can click and see about this tutorial. So in that particular tutorial we see that this is the basically dynamic graph which shows the maximum overpull and set down weight. And now we will discuss the next graph in this heading, that is working at depth graph, that is surface weight versus set down force graph. So here is the graph which we are talking about, that is surface weight and set down force, that is at which at a particular surface weight how much force or how much weight or how much slack off will be at the bottom hole. That will we understand with the help of this graph. But before discussion of the surface weight versus set down force graph, let's see the well profile for which we are going to explain, or for which we have generated this particular chart. So here is the well for which we have generated this chart. This is a horizontal well which is completed with the 958 casing and 7-inch liner, and finally this completion 4.5-inch completion is run, and the depth of this well is 11,025 feet. Here we can see this is the kickoff point, and then this particular section is the horizontal section. For this particular well we have run the simulation and has generated this surface weight versus set down force graph. This is a static graph useful at working depth. Unlike our previous graphs which we had discussed, those were the dynamic graph. Dynamic mean those graphs were giving us the value at each depth, but on the other side this is a static graph, that is it is valid only at a particular depth, that is the ultimate depth or our target depth for which we have run the simulation. This graph is applicable only for that particular depth. So for example, this graph we have run for 7,000 feet, that is the values which we will read by this graph are valid for 7,000 feet. If we change the depth, these values will be changed. This graph is used to know the weight on bit required during fishing and milling, etc. That is how much weight on bit we can apply in a particular well with a particular coil. This information we can obtain using this graph. The maximum weight on bit we can apply at this depth is 6,000 pounds. Okay, see this is the actual chart. On the x-axis we have surface weight and on the y-axis we have set down force. For example, when our surface weight, that is the weight indicator reading, will be 14,000, approximately 1,000 slack off will be on the bit. Now when we decrease the weight, that is from 14,000 we come to 12,000, it means we have dropped the weight on the bottom. So from 14,000 to 12,000, then the weight on the bit will be 3,000. Similarly, when our weight indicator reading will decrease, it means we are dropping the weight, that is we are putting the weight on the bit. So that's why it is a inverse chart, that is the surface weight decreasing, so it means correspondingly weight on bit is increasing. But the point to note in this graph is that this is not a linear graph. Linear mean from this 14,000 to 12,000 we have dropped 2,000, but at the bottom it will not be 2,000. Just see that from 14,000 to 12,000, this is the surface weight. But at the bottom, how much? At the bottom it will be when it is 14,000 it will be like 1200, and when it is 12,000 it is like 300. So the differential is 1800. That is on the surface. When you drop 2000 pound force weight, on the bottom it will be 1800. Okay, so it means the weight we drop on the surface is not similar which is acting on the downhole. Now let's see for the other two readings, that is from 12,000 to 10,000. When the weight we will drop from weight 12,000 to 10,000, at the bottom from the 12,000 it will be 3,000, and when it is 10,000 it will be like 4,400. So from 12,000 to 10,000 we have dropped 2,000 pound force weight on the surface, but at the bottom it is only 1,400. The reason is that in this particular section we are basically in the deviated section. Okay, so when we are in the deviated section, then the relation between the surface weight and the bottom hole weight is not linear. Okay, so this is actually the main point in this particular graph, is that the weight we are dropping on the surface is not the indication that the same weight will apply on the bit. As I just explained, that on the surface when we drop 2000 and at the bottom hole it will be 1800, and for the other values when it is 2000 then the bottom hole is 1400. So it means for each depth and for each value we have to refer this particular chart, and this chart will be different for each well. Okay, so this chart will tell us that how much weight we can apply on the bottom hole with the help by considering the surface weight, that is the weight indicator reading. Okay, now we'll compare the vertical and horizontal section of the well. So we have run this graph for 7,000 feet, and this graph is for 11,025 foot. Okay, and we have seen in the well that after 7,000 we have the horizontal section. So in this, for this particular chart we have seen that when we will drop 2000, at the bottom it will be 1800 pounds, and when we will drop 2000 for 12,000 to 10,000, the bottom hole weight or the set down force will be 1400 when we are in the vertical section. But for the horizontal section we can see when we dropped weight from 13,000 to 11,000, that is 2,000, on the bottom hole we are only able to drop 1,000. Okay, so this point we have to notice, that in the vertical section when we dropped 2,000 weight on the surface, at the bottom we are able to drop 1,800. That is, the weight on the bit is 1,800, 200 less. But in the horizontal section when we drop the 2000 on the surface, at the bottom hole we can only apply 1000 pound force weight. And for the second reading, when we have dropped 2000 it is 1400. Here for the 2000 we are able to set down only 800 pounds force of weight. So simply when we are performing milling job or fishing job, in these two jobs we need the set down weight, that is how much weight is on our bit or at the down hole. So for that we need to use this particular graph. So how to use this graph, we have already seen that we will see the surface reading. That is, for example, you just assume that our surface reading is coming out to be 12,000. Okay, and now we need to drop, let's say 500. Okay, so we will see from here that is how much reading is coming, then we will go like we'll see the differential. For example, just assume that for the 12,000 it is like 1200 something like that. Okay, so we have to, if we have to put the 500 pound force weight on the bit, so from 1200 will come to like 1700 and will come on this line. Okay, so it will be like this is 10,000, so like 12,000 and this value will be approximately 10,500. So it means to drop 500 on the bottom we need 1,500 drop on the surface. So this is the significance of this particular chart, that it helps you to determine that how much surface weight we need to drop to put a particular value on the weight on bit, and especially when we are in the horizontal wells, then this chart becomes very necessary and very useful, because in the vertical sections normally it is somehow linear, that when you drop 2000 it will be approximately 2000 or 1800, something like that. But when you are in the horizontal section it is completely different, as we have just seen that in the horizontal section when we drop 2000 it is only 1000, and in the other value when we drop 2000 it is only 800. So this chart is necessary when we are doing job in horizontal wells. So that was a discussion about surface weight and set down force. I'm very much hopeful that you got understanding regarding what we have discussed. So thank you very much. See you in the next tutorial.